Welcome back, Year 11. We're picking up here on page 16 of Booklet E. This is part 4 of Booklet E, so it's quite a slog to get through this booklet. And we're starting on with the quadratic formula and some problem solving around quadratic equations. So, first of all, what is a quadratic equation? Again, just remind ourselves, a quadratic equation is an amount of x squared plus an amount of x's plus or minus a number. Okay, but if we're going to solve the quadratic, it must be equal to 0. So if I've got things both sides of the equals and I've spotted, hang on, this is a quadratic, everything needs to come to the same side and leave nothing on the other side. That will then allow me to solve it. Now, we've done loads of factorising of these over the previous parts. This is specific to paper 2, okay, where you're going to end up with a quadratic equation. But the giveaway, well, there's a nice giveaway here because it actually says use the quadratic formula, which is this. However, if it didn't say that, it may just say solve, but give your answers correct to 2 decimal places. That's your giveaway, that we're not factorising here. If we factorise, we're not going to get answers to 2 decimal places. So we're going to need to use the formula. So we see that, give your answers to 2 decimal places. We spot it's a quadratic. In comes the quadratic formula, which is this. Okay, don't need to learn it. It's given in the formula sheet. What have I written in red? Notice in these questions it says solve correct to 2 decimal places. Where you have a quadratic equation needing solving to 2 decimal places, we use the quadratic formula rather than factorising. There we are. There's a note summing up exactly what I've just said. Now, in this one, there's a long way to go before I get a quadratic equation. I've got a bracket squared, so I've written that bracket twice and used my smiley face to expand it here. I've got x times this single bracket, which I'm going to expand here, and I've also got plus 7 there. So I've expanded my double bracket, I've expanded my single bracket with my plus 7, and I've made the call here to move these things all over to this side of the equation, leaving 0 there. And once I've tidied that up, I've changed the plus 2x squared to a minus 2x squared, taking it away from there. Changed the plus 3x to a minus 3x, taking it away from there. And changed the plus 7 to a minus 7 and taking it away from there. Okay, I get this quadratic equation. 7x squared minus 9x minus 6. Okay, the important numbers if I'm going to use the quadratic formula. A is the number before x squared, 7. B is the number before the x, in this case minus 9, don't forget the minus. And C is the loose number at the end, minus 6. Okay, the quadratic formula then. I like to use brackets, okay, so it's x equals, and we start with minus b, minus, but what's b? B is minus 9, so in brackets, minus 9, plus or minus the square root of b squared. What's b again? B is minus 9. Put it in brackets though, otherwise your Casios will get that wrong. Okay, minus 9 squared is 81. Your Casio will probably tell you minus 81. I'll explain that another time. Minus 4 times A, I'll put that in brackets, 7, times C, I'll put that in brackets, minus 6. All divided by 2A, 2 lots of A, but in this case A is 7, so 2 lots of 7. Notice that I've used brackets to substitute all my A, B and C values in there. Now, my preference, okay, rather than jump too far ahead of myself, is to just for a second work out this bit and this bit separately. Then we can split this up into our plus answer and our minus answer. So minus 9 is positive 9. Plus or minus, now, the square root of, use your Casio, put this in, okay? In brackets, probably can't see this, in brackets, minus 9, close brackets, squared, okay? Minus 4, open brackets, 7, close brackets. Exactly what I see, open brackets, minus 6, close brackets, and equals 249. Just check that you're getting that you're using the calculator correctly. So that's, I've taken care of this, minus minus is positive, and then this lot here is 249, divided by 2 times 7, I don't need my calculator for that. At that point, once I've worked this out, and I've worked out this inside here, that's when I'll split this up into x being equal to 9 plus this, divided by 14, and my second answer, x equals 9 minus this, divided by 14, giving you 9 plus the square root of 249 divided by 14 is x equals 1.77 to 2 decimal places, or x equals, this time again I'm on my calculator here, you can't see this, but 9 minus the square root of 249 divided by 14, and I get minus 0.48. Now I'm doing this in real time, so if there are mistakes here, don't trust everything that I've done, okay, and come to me if you spot any problems, but I'm hoping as I go along I've not made any silly mistakes. Okay, the one underneath it, while we've got a second, okay, just says solve this equation. Now, before I come back to it, just for a sec, bear with me, okay, and I'm going to move the page over to the bottom, page 15, which also said solve the following equation, okay. There's one huge difference which made this one a lot harder than this one, okay. The first difference is this. What I've got here is two fractions. Before I could do anything, I had to make the two fractions into one fraction by cross multiplying that times that times that, and that times that on the bottom, which is what I've got here. Then and only then, once I've simplified that, have I got a single fraction, and having a single fraction allows me to take what's being divided by up here, and that divide becomes 3 times all of that. But there's that extra step of making those two fractions a single fraction, exactly the same at the top. I'm not even sure I showed you this on the last video, but there it is. Okay, that times that, that times that, that times that become a single fraction. The 2 times 6 on the bottom becomes 12, but then that allows me to remove that divide by 12, that in the single fraction up there as a times by 12, and I can plot on, and actually this gave me a linear equation. This gave me a quadratic equation. Okay, now there was nothing here saying solve to 2 decimal places, so that was my cue to factorize to solve this. Whereas, back to where we were, here I've already got a single fraction. There's nothing, I don't need to combine two fractions into one. I can go straight to the step of, instead of dividing by 5x minus 3, take that up there and multiply x by 5x minus 3. Remember to put that in brackets so that it all gets times by the x, which is what I've got there. So x times this, 5x squared, x times this, 3x, but because that's minus, plus times a minus is minus 3x. Again, not quite there though, because I've got my x squared, I've got my x's, but I'm equal to 7, and like we said earlier, we've got to be equals to 0, so this 7 must come over as negative 7, giving me my quadratic equation equals 0. And then I take the hint here, give your answers to 2 decimal places to tell me, no, I don't factorize this one. This is where I use the quadratic formula, which is what I've done. Okay? Have a go at using the quadratic formula. A is the number there, 5. B is minus 3. Again, you've got that problem with the minus, and minus squared. And C is minus 7, and hopefully you kind of get to those answers there. Over the page 17 for me, to the top. 2-part question, part A, part B. Part A was show that this is equal to this. Don't worry about the kind of triple line equals, meaning identical to. All you had to do is kind of expand your double brackets here. Okay. You've got a bracket squared there, so I've written the bracket twice again and used my smiley face to expand that, which is here. One thing I would say about this, note this, because it's minus this bracket squared, when I've expanded these double brackets here, I've left that minus and put everything in brackets. It's because that minus is not just attaching itself to the first thing. Once we've expanded the brackets, that minus has to attach itself to everything. So minus 4. Minus 9w squared, and here we've got minus 6w, combined makes minus 12w, but it's minus 12w, so on this line you can see that's plus 12w. Once I've done that, and I've kind of collected like terms, 10w squared minus 9w squared is w squared, minus 7w plus 12w is plus 5w, and minus 3 minus 4 is minus 7, which is what I was asked to prove. Then comes the using the quadratic formula. Not such a nasty one, this. Let me move it down slightly. As you can see, the number before the w squared is 1, so a is 1. The number before the w is 5, so b is 5, positive this time. And the number at the end on its own is -7, so c is -7. Again, look, for consistency, I probably want to leave that in there. But again, because b is positive this time, minus b is literally -5. Okay, so I've got that there. Again, check. Put that bit into your calculator inside the square root and check you get 53. Make sure you're doing that right. And then you should kind of lead on to the solutions quite easily. Up to here. Again, pause if you want. Nothing too much to say about here. I've expanded the double brackets. Again, though, because it's equal to 7, and I've noticed I've kind of got a quadratic equation, but at the moment it's a quadratic equal to 7. Don't want that. 7 comes over as -7, leaving me equal to 0, and then my new quadratic, bless me, A, B and C values, in they go, quite big numbers this time. I haven't got answers here, however, back to calculator. First answer, 7 plus the root of 1537 equals, divided by 12 equals, that one is 3.85, and this one, 7 minus the root of 1537 equals, divided by 12 equals, minus 2.68. Time again, not really on my side in this video, so all I'm going to do here is just get you started, okay? And hopefully that'll be enough for you. What we've got here is a fraction equal to a fraction. It's a slightly unusual setup. If, say, that was just 1 there and wasn't a fraction, the first thing I would do is, instead of dividing here, I would take that up to get rid of the fraction here. However, if that wasn't there, the first thing I would do here is, instead of dividing by x plus 3, I would take that up there. Alright, the equals in the middle allows us to do that, but what we're going to do is do both those things at the same time. Move that up there as a times and move that up there as a times. So it basically becomes 7x plus 1 times this, x plus 3, okay, use your smiley face or foil, equals 1, and that's gone up there, times 5x plus 2. It's a single bracket, but because that's a 1, it's just 1 times that and 1 times that, so there's nothing to say about that. Let me get you your quadratic. You can go then on to solve it. 7x squared plus 1x, which is that, plus 21x, which is that, plus 3, equals 5x plus 2. Move both these things over. They're both positive there. Both are going to become negative over here. 7x squared. 1x plus 21x is 22x, but when I take away that 5, it comes down to 17. Okay, and we've got plus 3, but when I bring that plus 2 over as minus 2, 3 take away 2 leaves me with plus 1, and I've got what I need equal to 0. And again, my clue there, 2 decimal places, so a way to go with using the quadratic formula to find 2 answers for x. Okay, these will 100% be in paper 2 though, okay, the 2 decimal place stuff, the quadratic formula stuff. Let's move on. Simultaneous equations. This is a quick kind of reminder for you. Unless my x's are already equal, my preference is to make the y's equal. So what I've decided to do is multiply this by 3 to make 12y, and this by 4 to make minus 12y. But everything here gets multiplied by 3, there it is, and everything here gets multiplied by 4. The reason I've stopped there is to remind you, then, once my y's are the same, have the same coefficient, both 12, okay, I look at the plus and the minus and I say, well, they are different signs, so I need to remove them. I need to add these equations together. 9 add 8 is 17x. The reason I'm adding is to remove these, to cancel these out, and 21 add 64 is 85, and if my calculations are correct, 85 divided by 17 is 5, so x is 5. Once I know the value of one letter, I take one of my original equations and substitute this back in. So instead of 3x plus 4y equals 7, I know now that x is 5, so I will write 3 times 5 plus 4y is 7. 15 plus 4y is 7. loose number over that. Opposite of plus 15, minus 15, okay? So 4y is minus 8, giving y as minus 8 divided by 4, which is minus 2. Okay, move that on to the next one. I notice I say okay quite a lot. I'm going to try and stop doing it. This one. Same signs, subtract. But before we do that, okay, these, I did it again, these y coefficients, these numbers before the y's, we need to make them equal. I'm going to times this by 5 to make him 15, and I'm going to times this by 3. So my pair of simultaneous equations are 20x minus 15y equals 10, and my second one is 18x minus 15y equals 3. Now I use my same sign subtract. Let's put a big take away there. 20 take away 18 is 2x. Why do I subtract in this case? Well, let me just point out to you. Minus 15y minus 15y is what I'm doing here. So the minus becomes plus. So we're left with minus 15y plus 15y effectively, which is why they kind of go. You don't need to know that. As long as you remember same sign subtract, you're away to go. And 10 take away 3 is 7. 2x is 7, so x is 7 divided by 2. Alright, and without the calculator, I'm hoping you know that's 3.5. Substitute it back in, not the nicest because they're both negatives, but I'll put them into the top one. So 4 lots of 3.5 minus 3y equals 2. There's a few things I don't like here. Don't like the fact that's negative. Take you over there and return you in the other direction. 2 times that would be 7, double that, so that's 14. Bring the plus 2 over as minus 2 and be equal to positive 3y. 12 equals 3y. 12 divided by 3, don't know if you see that, equals y. So I'm already here, 4 is y. So x is 3.5 and y is 4. The alternative here that you need to spot is where you might have 2 equations you could form. So we're told the perimeter of this shape is 62. So this add this add this add this is 62. Or 4 lots of that is 62. And here, the perimeter of this is 72, so this side, this side, this side, and so on, equals 72. And because it's an octagon, there's 8 lots of that, which is what I'm working out here, being equal to 72. Here are my simultaneous equations. I'm not going to answer this one. Just remember, okay? Actually, I'll take you through the first step. Looking here, it'd be quite difficult to make these the same, even though that's my preferred method. However, the x's are already the same. Now it's not written, but they're both positive, so we can jump straight to same signs, subtract. And I'm going to do top take away bottom. 8x take away 8x disappears. 16y take away 12y is 4y. And 72 take away 62 is 10. If 4y equals 10, y is 10 divided by 4, which is 2.5. And you can substitute that in and get a value for x for me. Same here, let's do this in 2 parts. So 2 shapes, 2 equations, 2 unknowns, x's and y's, so simultaneous equations. This one tells me the area is 72, so length times width, that times that is 72, gives me that equation. What I did spot here though, is they're all pretty big numbers. Right? Now you could have gone along with that and it would have worked, but if everything can be divided by a certain thing, in this case they can all be divided by 12, do it. Okay, so this, divide that by 12, and that becomes 2x minus y equals 6. And this one, it tells me the perimeter is 33. So 3x add 3x, 6x. Y add y, 2y. And altogether, 6x add 2y is equal to 33. There are my 2 simultaneous equations. I've chosen to double this equation to make the y's equal. And then I'm using, and which I have, yes I have, different signs, add, minus, plus, different signs, add, and I'm away to go. Found what x is, substituted it in, and found what y is. I would go at that. For the last minute here, okay, I think you're going to be fine with these. Let's just have a look at them quickly. All right. Rearranging formula, changing the subject, make C the subject here, but my little note here, which I think we wrote in class, hopefully says, remove fractions, remove brackets, and then collect subject terms one side and anything else the other. So that's exactly what I've done. Moved the bottom of this fraction up, okay, in a bracket. So I've removed the fraction. Then I've expanded the bracket, g times that and g times that. Then I thought, well, let's get anything with a c in it to this side, and anything that doesn't have subject term c's over the other side. And then the difficult bit, there to then, okay, because I can't do 6c minus gc, this is the bit where I need to factorise, take the c out and leave in my bracket 6 minus g. What I'm saying is this is the same as c times 6 minus g, and that allows me then to slide that underneath there. The next one, have a look at it. Expand the bracket, collect the subject terms one side and everything else the other. Pretty straightforward. And the bottom, the same. Remove the fraction. That times that is equal to that. Expand the bracket and then collect anything with a c this side, anything without c's the other side. Factorise and slide that underneath. Now, I think we're going to run dead on power, but then there's that last one on the back. The other one, the one that's slightly awkward that I was going to have a look at is this one. But what I think I'll do is I'll leave that till the start of the next video. So it'll be part of booklet F. Okay, that's it for that one, and see you all soon.